Hello, everybody. My name is Andreas Dionisiou, and in this presentation, I'm going to talk about Modssl hmac, which is practical password hardening based on TLS. To address the major threat of password leaks, services have started to employ password hardening techniques. Two major families of password hardening techniques exist today. The first one is to use on-purpose slow cryptographic hash functions in PyCrypt. These cryptographic hash functions are designed to adapt to hardware evolution. The slowdown is by design for slowing down the attackers that they aim at cracking cryptographic digest offline. Unfortunately, no matter the slowdown, if the password is weak and due to the evolution of the hardware, then it can be still guessed. The second family of password hardening techniques is based on using a cryptographic service constructed entirely for the purpose of computing hardened passwords. Hardening here involves several rounds of cryptographic hashing and message authentication codes, hmac. With such a service in place, verifying a password means involving the service. This essentially transforms offline password cracking to online. Modssl hmac is a password hardening service which can be deployed immediately by a web application serving content over TLS, which is of course the most common scenario. Modssl hmac does not use cryptographic hashing for storing passwords, but rather an hmac which involves using the TLS private key of the web server. Modssl hmac does not expose any sensitive key to the web application, and instead leverages existing cryptographic elements which are already stored in the web server. Modssl hmac is a modified Modssl, the standard Apache module for TLS, which, in addition to every TLS encryption, supports hmacs of messages with the TLS private key of the web server. Although Modssl hmac does not prevent password leaks, the cracking of passwords once they are leaked, becomes possible only if the TLS private key of the web server is also leaked. However, in this case, we consider that the threat model of the password leaks is no longer relevant, since an attacker can now launch far more stronger attacks, such as impersonating the web server. So let's see an example when we have Modssl hmac in place. As you can see in the first figure, although the attacker has managed to leak a significant amount of passwords, he soon realizes that those passwords cannot be broken, and he cannot derive the plaintext format of those passwords because they are encrypted using the server's TLS private key. In other words, in order to derive the plaintext formats of those passwords, the attacker has to also leak the TLS private key of the server. However, if such a sensitive element is leaked, which is the TLS private key of the server, the attacker can launch far more stronger attacks. So we consider that the threat model in such cases, the password leaks threat model in such cases is no longer relevant.